Welcome to Physics Lab 1, where we are learning about constant velocity. In this lab, we pushed a cart on a track in order to make it experience constant velocity, and then compared its constant velocity to simulated constant velocity via GlowScript. What even is constant velocity? Constant velocity is when an object is moving in a straight line at a constant speed, meaning both the magnitude and direction of its motion remain unchanged over time. Why are we doing this lab? The purpose of this lab is to learn more about constant velocity and compare it to simulated constant velocity. We are going to find out if simulated constant velocity is accurate, and how it compares to real-life constant velocity. What were the results? The results of this lab showed that simulated constant velocity is just as accurate as real constant velocity. The only differences were in the graphs that were created from the data, but that is due to one being a measure of the absolute value of position versus time, and the other being a quantitative measure of position versus time. The experiment. In order to simulate constant velocity in real life, we used a small cart and rolled it on a fixed track. After experimenter A releases it, for a short time it will experience constant velocity. Once it hits experimenter B's hand, the constant velocity is over, and we can begin to compute the data. Physics at play. The main physics principles being implemented in this experiment is obviously constant velocity, but there are a few more. The initial velocity and acceleration of the cart are important to the cart's constant velocity, and what about the net force acting on the cart? Since the cart is at constant velocity, that would mean the net force acting on it is zero, therefore the cart is at equilibrium. These are the useful equations for this experiment. The Tracker app was useful for calculating our real-life constant velocity. Using the video from the experiment and setting the distance of a meter using a meter stick, it was able to measure the constant velocity of our cart by placing dots in the center of the cart's mass. GlowScript is our digital comparison. By manually changing some of the code given to us in a model to fit our real-life data, we were successfully able to simulate constant velocity in GlowScript. The first section of code shows the initial conditions of the ball in the GlowScript simulation. It was 0.365 meters to the left of the origin and traveling at nearly 2 meters per second to the left as well. The second section of code shows how long the calculation loop would run, which was from the moment the constant velocity of the cart began to the moment it ended. The final section of the code shows the velocity and position update of the digital ball that will be simulating the real-life cart's constant velocity. This is the 3D model and graph GlowScript came up with using the constant velocity data from our real-life experiment. Analysis. While the graphs do look different, they are portraying the same message: constant velocity was attained in this lab. The GlowScript graph is taking direction in regard to the origin into account, while the tracker data on the left is not. They both show a linear relationship, so constant velocity was achieved and we can accurately simulate it. In conclusion, we are able to accurately simulate constant velocity using different programs. While the graphs looked different, the results were the same. The U/SIC/GA bull snobs would never have been able to figure this out. THWG and have a blessed day.